for the YouTube stream from the Shy Hat channel over here. And if anybody wants to participate over from the YouTube channel, you can, and you can access it at this link right here, which I'm sharing with the chat. Okay, so let's get started. Once again, if you don't have an account over at tryhackme.com, please try to make one, because we're going to be using this website for one of our exercises today. But in the meantime, let's go ahead and do a short review of what we learned last time. So this is HackerFrogs After School Web App Hacking Basics Part 4. This is the fourth Intro to Web App Hacking workshop. In the previous workshop, we learned about the following web app hacking concepts. Okay, user P says no, they can't. I'm going to ask you what this is in reference to. Okay. All right, so we learned a little bit about source code analysis last time. It's the process of analyzing a piece of code of software with the goal of deeper understanding regarding its function. We did a little bit of software reverse engineering to try to understand what was going on inside the web app. It's a common technique used in software security testing, but it requires the software source code to be readily available. So a lot of the time, we are not able to see the source code for the website, and so a lot of the time we can't use source code analysis, but sometimes we can. Okay, we also learned about URL parameters. URL parameters are variables attached to the end of URLs. They're often used to send search queries to web servers, but they can be used to retrieve other data as well. Okay, so everybody, we need to do a little audio check, because some users are saying that they can't hear me. So if you can hear me, please type "I can hear you" in the chat. And if you can't hear me, then please type that you can't hear me. So I'm wondering, to the people who can't hear me, I wonder what is going on. Okay, so let's continue. Okay, and we also learned about local file inclusion. So local file inclusion, also known as LFI, is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. So I'd like to ask the people in the chat if you were able to understand what was happening when we did our local file inclusion attacks on the web applications yesterday. So did you understand what was happening when we were sending the dot slashes and we were accessing the files on the web server? If you think you understood, please type that I understand. If you didn't, then type I didn't understand, because I want to get a gauge for whether or not these concepts are being easily understood. Okay, so we're going to continue where we left off in the NATAS CTF. That's going to be NATAS level 8. Is it level 8? Let me take a look at the document over here. Okay, we're starting from NATAS level 9, actually. So some people say that they did not understand. Okay, so I might do a little bit of explanation at the end if you're interested in staying behind a little after the session, and we'll talk about the LFI vulnerability. Okay, so to everybody else, let's go over to NATAS level 9 so that we can introduce today's concept. Okay, so I'm going to copy this link address and put it in the chat. Okay, and let's navigate there in my own web browser over here. So on this page, we're going to have to supply a username and password. The username is going to be natas9, and the password we can get from the GitHub link. And the GitHub link I'm going to provide to everybody in chat right now. In the GitHub link, you will see all of the links that we're going to be using in this lesson today. So down a little bit, we've got NATAS CTF links and passwords. And you'll see under NATAS level 9 this password right here. So what we need to do is we need to copy it. Just highlight that and copy it. And then go back to the NATAS webpage and use this as the password to log into NATAS level 9. And then click on sign in. Okay. All right, so if you are able to log into NATAS level 9 and you see this webpage right here, please type in the chat NATAS 9 smiley face. If you're having trouble, please let us know in the chat and we'll try to help you out as best we can. So one more time, if you're able to log into NATAS level 9 using the username NATAS9 and the password located on the GitHub link, which I will provide in the chat, please type in the chat NATAS9 if you're able to log into this page here. Okay, so we have a couple of people responding that they're on NATAS level 9. So to the people in the YouTube chat, if you need the links that we're using today, right now, I will, I shouldn't have done that. I'm also providing them in the YouTube chat. Thank you very much. Okay, so if you're here, then that's great. If you're not here yet and you need assistance, please let us know. I'm going to explain today's concept for everybody, and we're talking about OS command injection. So let's explain what that is. So we're talking about OS command injection. This is another type of web app vulnerability. So this is a very serious web app vulnerability where arbitrary OS commands can be performed on the web server through a web interface. So basically, this means that we can run commands on the underlying web server, and it's a very big problem if it's present. OS command injection is a serious vulnerability and can often lead to complete compromise of the web server. And if so, the web server can be used as a foothold to attack other machines on the network. So if there's a web server with OS command injection on it, then bad guys can take over the web server using OS command injection and start attacking other machines on the network. That's bad news. So what we're going to do is we're going to go to NATAS 9 and we're going to demonstrate how this app is vulnerable to OS command injection. All right. So we've got a web app over here, and it's basically some sort of dictionary app. It says find words containing something something, and there's a search bar. So if we plug in something like test and we hit search, then it's going to output a bunch of words that have the word test inside of them. So whether or not this is accessing some sort of file that's on the web server, we don't know. But if we go back, then on this page, there's this section right here labeled View Source Code. So let's take a look at that. So we can just right-click on the View Source Code link and put this in a new tab. And then click on the new tab. And then down towards the bottom, there is a bunch of code. All right. So does anybody remember what kind of code this is? If you know what kind of code this is, it's not Python code, it's something else, then let us know. The special thing about this language that we're talking about right here is these bracket question marks over here. Some people are guessing it's HTML or CSS. It's not these in this case. So if you see the bracket question mark, then that's a big giveaway that this is PHP code. So PHP code is a type of coding language that is used for websites. And in particular, what this is looking for is it's looking for a variable. There's a variable being made called key right here, and it's going to be passed into some sort of function. And the function over here is this pass-through function right here. So if we ask something like ChatGPT what the PHP pass-through function is, it'll probably give us a good answer. And I actually want to encourage using more chatbots like ChatGPT to ask questions about cybersecurity stuff. So if we go over to ChatGPT and we ask, what is the PHP pass-through function? And we ask this. So this function is used to execute an external command and directly output the raw result of the command without any modification. It's part of a set of PHP functions that allow interaction with the underlying, with the underlying operating system. So this phrase right here, underlying operating system, this gives us a clue as to how this is vulnerable to OS command injection, because it basically executes operating system commands. And in this case, we're dealing with Linux, so we can execute Linux commands. So if we look back at the code over here, this is giving a Linux command right here. Does anybody remember what the grep command does in Linux? If you know, type in the chat. If not, I'll explain it in just a few moments. But we're actually executing this Linux command right here, grep-i, and then the key variable on the dictionary.txt file. Okay, so user NS says it searches the code for a keyword. So yeah, so if you use the grep command, then you're going to pull out any anything that any string that you specify. So grep is going to pull out. It's kind of like a search inside of a file. So what the grep does in this case is it's going to pull out the string in this dictionary.txt. So I guess it's a dictionary with a lot of words. And if you take a look back at the web app over here, so we imagine that we're using grep on this dictionary.txt file with the string test. So if we execute this, then it basically pulls out all of the words where test exists in the line. Okay. So I'm going to explain. So this is the command that we're using right now. So I'll also explain how we can exploit this particular bad code to do OS command injection. So inside of Linux, this command right here, the semicolon, this is going to stop a command. So if you go to, if we're using JS Linux, let me grab JS Linux just a second. So if we have JS Linux over here and we do who am I, and then we do semicolon, this is going to stop the command. So run this command basically. We can also supply additional commands. So who am I, and then pwd. So it's going to show the current user and then the current directory. So it does both commands one after the other. So it shows us who we are, we're root, and then the present working directory, which is the root directory. We can use this right here to do OS command injection, to inject our own command. So on the web app, we do the semicolon to stop the command, and then we're going to ask who am I. So this command is going to stop the current command, and then it's going to do who am I, and we're going to do one more thing. And the one more thing we're going to do is we're going to add a comment. So the comment is used. So we're able to do a comment inside of Linux by using this right here. So this hash symbol. And the hash symbol basically says that everything that comes after this on the line is a comment and is not going to be executed. So we stop the command, we give our own command, and then we comment out everything that comes after this on the line. So if we take a look at the command right here, we've got grep I. This is the first part of the command. And then we put the semicolon, which stops this. And then we put in our own command right here. And then we comment out this dictionary.txt because we don't want this as part of our command. So we isolate the command that we want to run by canceling out everything else. So if we do this inside of the web app and we click on search, then what we did is we got the username right there, which is what we wanted to do. And so we're able to inject our own command and run it on the web server. So this means that we have OS command injection on this web app right here. If there's anything that you don't understand about what's going on, then please type in the chat, and I'll try to explain what exactly is happening when we use this OS command injection exploit. Okay. But so what we need to do is we need to read the file that contains the password for the next level. So this level is NATAS 9, and what we need to do is we need to get the password for NATAS 10. If you remember from yesterday, the NATAS 10 password exists inside a specific directory. So the specific directory that we're talking about is the /etc/natas_web_pass directory. And then if we want to read the password for NATAS 10, it would be this directory right here, and then NATAS 10. Okay. So how does anybody know what command we would use to read this file inside of Linux? Okay. Some people are responding with the cat command. That's true. So we could insert our own command, which would be to cat this file right here to get the password for the next level. So what we need to do is we need to use the semicolon to stop the command that is being used by the web app. And then at the end, we need to provide the comment to comment out the rest of the line. Okay. So let me demonstrate this in our little presentation over here. So this is the command we're using to access the password file. So number one, the semicolon is going to terminate the command. Number two, the cat command is going to read files. Number three, this is the file path to the NATAS 10 password file right here. And number four, the hash symbol is going to nullify or comment out anything that follows after this on the line. Okay, so let's run this command. So back on the web app, we've got our. So if anybody wants, so I'm going to paste this in the chat just for reference. If you wanted to copy this. Okay, so let's run this command right here. And this is the output, and this is the password for the next level, okay? All right, so we can just copy this because we're going to be using it to access the next level in just a little bit. So just copy it. And we're going to log in to the next level, everybody. So what we need to do is we need to get rid of everything in the address bar over here, and we need to plug in the number 10 for NATAS 10. User LC says it didn't work for them. That's strange. Okay, so are you on NATAS level 10? And do you see this screen right here? So if you do colon, semicolon rather, if you do semicolon, who am I, and then hash, do you get the password? Do you get the username NATAS 9? Okay, so yes. Okay, so all right, so you get the NATAS 9 when you use the So it's semicolon and then who am I and then hash, and you do get the natus9. So let's try this again. So it's going to be semicolon and then cat and then slash etc slash natus underscore webpass slash natus10 space and then the hash symbol again. So try typing this out once. Okay, so remember slash etc slash natus underscore webpass slash natus10 and then hash and then click on search and you should get the password over here. Okay, so it worked for user LC, user CT. Were you able to get the command to work? No. Okay. So let's try this one more time. So it's going to be semicolon space. Oh, you've got a spelling error in your command, user CT. So it's you spelled it ECT and not ETC. So I think that might be the reason why it's not working for you. No worries. We all make spelling mistakes. I also make a ton of spelling mistakes myself. So no worries, no worries. So yeah, that's why it's important to get other people to take a look at it, and they can probably spot errors that you don't see because it's hard to spot your own errors. Okay, so everybody, let's copy the password and log into Natus level 10. So let's get rid of everything except for the base URL. We're going to Natus level 10. And we're going to put in natus10, natus10 as the username, and the password, we're going to paste it in. Click on sign in, and all right. Okay, so now that we're on Natus level 10, if you're having trouble accessing Natus level 10, you can always go over to the GitHub. And let me paste in the GitHub for everybody. And I see some people, somebody in YouTube chat, Zohybe. Zohybe, hello. Hello, nice to see you. Hack the planet. Hey. We're just doing a little lesson right here. We're talking about OS command injection. So if you're having trouble accessing Natus level 10 on the GitHub link, which I just provided to everybody, you can see you got the link over here, you got the username, and you have the password. Okay? So everybody, if you manage to access Natus level 10, please type in the chat Natus 10. Smiley face. Okay, so we're just waiting for people to catch up. If you're ready to do Natus 10, please type in the chat Natus 10 smiley face.
I'm system root.
Thank you for the video redeems, Zohybe on YouTube. Thank you very much. Okay, so over on Natus 10, it says, for security reasons, we now filter on certain characters. Okay, so this means that this is basically the same level as the last one, except that it's a little bit more difficult. Okay, it says we now filter on certain characters. If we try the same thing that we did on the last level, so who am I, semicolon who am I hash, and we try this, it now says input contains an illegal character. So it's basically the security is better on this web application, and it can now detect if we're trying to use characters that can be used in OS command injection. Okay, so we're going to take a look at the source code for this web app. So we can just go over to the view source code link, and put this in a new tab. And we're going to go down, and we see one more time that we have our PHP code over here. So in YouTube chat, user Zohaim asks, "Did you watch the video?" Yeah, I did watch the video that that you linked to me yesterday. It was a very interesting video. Thank you very much. Okay, so we've got the same app that we had last time, except it has this line of code right here. So if there's a match in the input for these characters, and these characters are these ones right here, then it's going to print out input contains an illegal character, and it's not going to let you run the command. So the illegal characters are the semicolon, the pipe character, and the and character over here. So if we can't use these characters, how are we supposed to do our OS command injection? So this is, if anybody has some sort of idea on how we can get around this, let us know in the chat, and then we'll try to talk about it. Okay. User LC says use pipe. So in this case, the pipe character is an illegal character, so it's going to say that it's not going to let us use that pipe. But let's demonstrate this. So if we were to put pipe in the input and then press search, it's going to say that input contains an illegal character. So the interesting thing about bypassing the filter in this case is understanding how the web app works, right? So the web app works right here by using the grep command on the dictionary.txt file. So the interesting thing about the grep command is that you can supply multiple files to the grep command. So for example, you could grep for inside of dictionary.txt, and you can grep inside of another file. So if you know that you can grep in multiple files, what can we do with this information? Does anybody know? So the answer is, if we can use grep inside of multiple files at the same time, we can just use this command normally to grep inside of the dictionary file and also grep inside of the password file. So how would we find the password if we're using grep to grep inside the dictionary file and grep inside the password file? Does anybody know what we would do to do that? In actuality, we don't need to grep inside the dictionary file, because inside of the illegal characters right here, the hash symbol isn't included as an illegal character. So we can actually use the hash to get rid of dictionary.txt. So in this case, we can use grep to grep inside of the password file. And to grep inside of the password file, we just need to supply grep with one letter or one number that's inside the password. So let's demonstrate this. I will show you the command we're going to use. So we're going to use this right here. So it's A and then slash etc slash natis webpass slash natis 11 to read the password for natis level 11. And then at the end, there's the hash symbol. Okay? So the first thing that is part of this command is an argument to the grep command. So we're going to use grep as intended, but we're going to search for the letter A. So if the password has the letter A in it, then it's going to show the whole password, because it shows the line that has the string inside of it. Next, we specified the file that's going to be searched, which is the natis 11 password file over here. And the last thing we're going to do is we're going to supply the hash at the end, which is going to nullify or comment out whatever follows next on the line inside the web app. Okay, so let's try this. So in NATS level 10, we're going to look for the letter A, and we're going to, we're looking for the letter A inside of this file right here, which is the NATS 11 file. And we're going to supply the hash at the end to get rid of the other file, which is the dictionary.txt file. Okay, so we're going to search, and we get the password. And the reason we get the password is because the letter A is in the password, and we're able to use grep to read it. So if you want the command that we used for this web app, I'm going to put it in the chat. Okay, so let's go over it one more time. So we're looking for the letter A inside of /etc/ natus underscore webpass /natus 11 and then space, and then we supply the hash or number sign right here. Okay, after we've done that, click on search, and we get our password for the next level. Okay, so user LC says it's not working. Okay, so why don't you paste in the command that you used into the chat, and we'll see if we can look at it and make sure that there are no spelling errors or other syntax errors in it. Okay, so it's it's A and then /etc/ natus underscore webpass /natus 11 and then space and then hash, and then press search, and you should see. Okay, so I'm looking at user LC's command over there. It looks like it should work, but so this is what I'm going to do. Okay, I'm going to put this command inside of the GitHub. So I'm going to edit the GitHub for just a second. Okay, so the command is now in the GitHub underneath NATS level 10. If you're having trouble, try copying this on the GitHub, and I'll supply the link for the GitHub. So go to the GitHub page, go down to NATS 10, and then copy this, and then go over to NATS level 10, and in the search bar there, paste in the command, and then click on search. Okay, so user LC says it still doesn't work for them. Why don't you stay after the session is done, and we'll try to troubleshoot your problem for you. Okay. But so if you're able to get the password, and if you're able to get the password and log into NATS 11, so we're not going to solve NATS 11 today, but we're just going to use the password to log into NATS 11 just to say we can. So everybody, if you were able to finish the level NATS 10, please type in the chat NATS 10 done. Smiley face. And if not, then let us know, and we'll try to give you some assistance. Okay, so just to do a little bit more practice on OS command injection, we're going to do an exercise on picoctf that deals with OS command injection, all right? So we're going to go to our picoctf and we're going to do this challenge right here, which is called CAS. All right, so I'm going to provide the link in chat for everybody. So this is picoctf CAS. So I'm going to give everybody a couple of minutes to log into their picoctf and to access this page right here. And if you are on the page and you see the CAS exercise, please type in the chat CAS, smiley face. I'll wait about a minute and hopefully everybody's able to access this page without any problems. So what is this challenge right here? So we've got a medium level challenge in the web exploitation category. So so it's referred to in picoctf as web exploitation, but I like to use the word web app hacking because I do YouTube videos and YouTube videos don't like this word right here. So I try not to use this so much when I'm talking about hacking web apps. All right, so I see some people they're on the page and they say CAS and I say CAS. Okay. All right, so if we're on this page here, there's also what is called a challenge endpoint. So this is basically a supplemental file for this particular challenge. And it's this file called index.js. So this is some JavaScript. So JavaScript is, so this is basically our version of looking at the source code for this page. So we can right click on this and put this in a new tab. And it's going to download this for us. So on your computer, you can go over to wherever you downloaded this file, index. You can right click on it and maybe we can edit it in Notepad. So we can use some sort of file to take a look at it. If you can't open it with your text editor, that's fine. We're just going to examine the code for just a little bit. Let me make this nice and big so that we can read it. Okay. So we've got this this JavaScript right here, and I don't expect people to know exactly how JavaScript works in order to examine the code. What we learned from Python should be able to let us get a rough idea as to what's going on inside this code. And basically, we've got a variable called exec right here, and the exec variable, well, you just have to know that there's a function inside of JavaScript called exec, and this exec function is going to run commands on the web server. So it's basically using OS commands with the web app. So that if that sounds familiar, because we use these kind of functions to do OS command injection just now, then that's true. So what the program's doing is that it's running this program right here. So it's running a program in this directory, user games cowsay, and it's using our variable over here as the argument for running this program right here. So if you want to understand what exactly is going on, we're going to demonstrate by going over to the website that's associated with this web app. Okay, so over on picoctf, there's the link here, cowsay as a service. We can right click on it and put it in a new tab in our web browser. So it says on this page, cowsay as a service. make a request to the following URL to cowsay your message. And it has a link right here. So there's the beginning of the link. And it also says that you have to supply a message after the slash over here. So you can copy this. Make sure not to copy the message portion and then copy the URL. Then go up to the top of the address bar and paste in the address. And on the end, we're going to type the word hello. So the top of the address bar should say /cowsay/hello. And then hit enter. And then what the program does is it creates this this ASCII art over here of a cow, and then your message is put inside the speech bubble over here. So it says hello right here. Okay, we can also change the message from hello to something else. Maybe we are HackerFrogs. Okay, and it says we are HackerFrogs. Awesome. All right. So does anybody know how we would take advantage of this application to do OS command injection? If you know, type it in chat. Okay. So user LC says in the message, where it asks for the message, okay, you input something. You input the command. So if you input the command directly, that's not going to work. So if we wanted to do who am I, and we wanted to run the command, it's just going to say who am I in here. Okay, so user LC says you have to start it with the semicolon or use the semicolon. Okay, so we can use the semicolon. So we're going to start the command over here with semicolon who am I? Who am I? And we hit enter. And the server is just thinking, oh, it didn't work. Okay, so this didn't work. I think what we need to do is we need to put in something legitimate for this command first. So we're going to do we are HackerFrogs, and then we're going to do semicolon. And then after the semicolon, we're going to put in our own command, which is who am I? And then hit enter. So the first part is executed successfully. It says we are HackerFrogs, and then it says node over here. So who am I? The answer is node. So, all right, so we need to find the flag. Does anybody know how we could find the flag now that we have access to the web server? So we can run basically any Linux command. So we just have to make sure that we put in something and then put the semicolon, and then after the semicolon, we can put in whatever command we want. So how would we find the flag? Does anybody have any ideas? So does anybody remember how to, does anybody know how to list out the directory contents inside of Linux? Okay. Okay, user LC says that it's the ls command. PWD is going to tell you the name of the directory that we're in, but ls is going to list out the files. So over here, we can use ls. So at the end over here, so if anybody's wondering what these what this %20 over here means, there are certain special characters inside of URLs that are converted over to what is called URL encoding, and it basically turns special characters into %number. So in the semicolons case, it's %20, and in the case of the space, it's something else. Oh no, the semicolon is not. The semicolon is not converted, but the spaces are all converted to %20. Okay. All right, so just on the end of the command over there, we're going to do we are HackerFrogs and then semicolon and then space and then ls. So we can give this command and then it's going to give all of the files inside of this directory, okay? So it says, so somebody in the chat, user P says that it is this time for them. Okay. Yeah, so we're going to be finishing in the next 10 minutes or so. We're just trying to finish this challenge over here so that we better understand the OS command injection. So what the command what we want that we did to get this is anything. It could be hello and then semicolon space and then ls. So let me supply this to the people in chat who want to use this command right here. Okay. So if we give this command right here, then the cow says hello, and then the OS command injection shows us the files in the directory, okay? So does anybody know how we would read? So which file do you think has the flag? So this is misspelled on purpose over here, but this is the flag file that we're looking for. What command can we use to read this file? So we could use the cat command to read this file. There are actually a number of commands we can use to read files, but it's probably easier to just use the cat command. So over here, inside the address bar, we do hello, and then we do semicolon, and then space, and then cat folg.txt, and this is going to let us read the flag. Okay, and the flag in this case is picoctf moo. Well, it's kind of scary. It's getting towards Halloween season. All right, so let's copy the flag and then go back to the challenge and paste this into the challenge submission field and click on submit flag to finish the challenge. Okay, so everybody, if you managed to finish the challenge, please type in the chat moo smiley face. And if we could get a a little bit of a poll in chat, who made an account for tryhackme.com? If you made an account for tryhackme.com, let us know by typing THM smiley face in chat. I just want to know who has made an account over at tryhackme.com. So we were going to do an exercise over at tryhackme.com today, but it looks like we're running out of time, so we're not going to be able to get that done. But we can do one more challenge inside of picoctf, just so we can get a little bit more practice doing challenges doing web app hacking challenges. Okay. So the challenge, our second challenge for today is going to be this login challenge right here. Okay, so I'm going to copy the link for this challenge. And let's go over to the challenge right now. So this is the login challenge right here. We can just we can take a look at it. It says, "My dog sitter's brother made this website, but I can't get in. Can you help?" So this isn't necessarily an OS command injection challenge, but we can put this in its own tab and take a look. So everybody, if you manage to access this website over here, and you're ready to go, please type in the chat, ready to go. Smiley face. Okay, good to see, good to see. All right, so if you need help or you're having some sort of problem accessing the website, please let us know in the chat and we'll try to help you out. Okay, so if you access the website over here, so we've got a username and password field. We can just type in test and test for the username and password and click on submit. And we get a pop-up that says incorrect username. All right, so everybody, so if you feel like racing me to the end of this challenge, you can go ahead and do that. But use all of the different techniques that you learned in the classes so far and try to get the flag without me telling you how to do it. If you need help, I'll be walking through how to do this challenge in just a few moments. But if you want to challenge yourself, try to complete the challenge without my help. Okay, so what are some things we could test on this website? So we could test if there is a robots.txt, if you remember that. We can test and see if there's a /robots.txt file on here. There is not. Okay, what are some other methods we could use to test the page? Does anybody have a suggestion? Okay, so user LC says Control plus U. So that's the keyboard shortcut to see the page source. So we can view page source. We can do right click view page source, or we can do Control U, the keyboard shortcut. And we see inside of here, there's not necessarily a password or a username that we can get. But there are a couple of files in here that we can investigate. So what we can do is we can right click these files and put these in new tabs. This index.js, this is a JavaScript file. If we look at the index.js, so the styles.cs file over here, there's nothing really much to go on here. But if we look at this file right here, there's a lot of code, and it's all kind of squished together. So this is called I think this is called compressed code, and this is what you do to try to make sure that your files are as small as possible. So if we ever see this, what we can do is we can copy all of the code over here, and we can go over to we can go over to ChatGPT and ask it to make this code pretty. Okay, so we're going to do ChatGPT, make this code pretty, and then we're going to paste in the code. And then it's going to give us a much more readable version of the code. So the important thing to note over here is that it's looking for a correct username and a correct password. So this is encoded, and this is the string right here. So what do you think this string and this string could be? What kind of encoding do you think this might be? If anybody knows, let us know in the chat. So this is our favorite CTF encoding method, which is base64. So we could actually ask that we can ask inside of ChatGPT to decode this base64, and I think it'll give us the answer. So just ask in ChatGPT, decode this base64 for me. This base64 in the code, and then it'll analyze the code for the base64, and hopefully it's going to decode it for us. Otherwise, we could decode this ourselves by doing it manually. But it's thinking. Hold on. Okay, so it says the decoded values are username admin, and the password is picoctf server. So this is the flag that we're actually looking for. But just for fun, we can copy the flag and we can submit the correct credentials to the web app. So we know that the username is admin. We can just copy the flag and go over to our login page. Hold on. This one. So over on the web app, we're going to use admin as the username, and the password, we're going to paste it in and then click on submit. And it says, correct password, your flag is this. But we already had this flag already. Okay? All right, so user P is pointing out that it's getting close to the end of today's session. So I'll try not to go over time on today's session. So the last thing we need to do is go over to the challenge page, and in the login challenge, we're going to paste in the flag and click on submit flag to finish the challenge. Okay? So everybody, if you managed to finish the challenge, please type in the chat, "Oh, I logged in," smiley face. So to finish out today's session, let's do a little review of what we learned in today's class, okay? So let's review the web exploitation concepts we learned in this workshop. We learned about OS command injection. Operating system OS command injection is a web app vulnerability where arbitrary OS commands can be performed on a web server through a web interface. So OS command injection can often lead to complete compromise of the web server, and if so, the server can be used as a foothold to attack other machines on the network. So in the next HackerFrogs After School Web App Hacking Workshop, we're going to learn about the SQL database language, which most web apps use for user account credentials. So this database language, SQL, is used in almost all web apps to keep track of usernames and passwords in particular, but a bunch of other data as well. So we're going to learn how to interact with the system because we're going to learn how to hack SQL in a later class. So to everybody who needs to get going soon, including user P, it seems, we're going to be doing our next session on Friday, and it's going to be at the same time. If you can, please make an account over at tryhackme.com because we might be using this website in the future, okay? So to everybody who needs to get going, we'll see you on Friday and see you next time. But to anybody who wants to ask questions about any of the web app concepts that we were going over earlier, I remember user CT mentioned that they didn't quite understand the local file inclusion vulnerability. I'm going to end the